You would have heard 1,000 times that this is the best time to be in India. But where exactly in India? I think one of those answers is the automotive vertical. Welcome. This is Mukul Yudhveer Singh for Autocar Professional, and sitting with me is Dr. Suresh D, who is Group CTO for Minda Group, and Vikas Chaudhary, who is founder and CEO for HackersEra. Suresh sir, welcome. Vikas, welcome. First question to you, Suresh sir. About 20 years ago, they said that mechanical was the core of everything automotive.
Yes.
But today it seems as if that core has moved on to software and electronics.
Yes.
What else in terms of engineering for automotive has changed in the last few decades, and what else would change in the next decade?
Yeah. Thank you. I think fantastic question to start with. If you look the era where we are living in, is an era with complexity, and a comfort. People want more and more comfortable functions and features. When you start implementing it, then complexity goes up. If you look the old systems in the mobility, it was mechanical to mechatronics. Now more and more electronics, and this goes more and more towards the software, so called SDVs. So the era of electronics started a decade ago, and India is nowhere behind. India is also ahead of the curve compared to the rest of the world. So these modern automobiles comes with the intelligent systems, smart solutions, and also the secured devices. When you add a complexity into vehicle, you need a security, right? So it is changing, and bringing a lot more glory. At the same time, the complexities gives us a feel that vehicles have to be more and more secured, and we need to make, at the same time, we need to make the vehicle affordable. So that's where we are heading.
Let's peel more layers
Yes.
on that. Suresh sir, does reliability now mean that it is as much about hardware as it is about software?
Well, the reliability is a common term, not limited only to automotive, but every product, I would say, reliability is common. The hardware has to be reliable, and the software has to be more resilient. So it's a co-working of hardware and software. Finally, it gives more reliable product. So you can't keep this standalone of software and hardware. Same applies to automobile. When you bring a system with the changes coming in now in the era of powertrain changes, autonomous driving comes in, connected mobility comes in. Again, you have two parts. One is hardware, which is a hardware layer, which could be the normal discrete electronics, or could be a microcontrollers or microprocessors. But on top of it, where you have a hardware near software, base software, and then application software, and then this goes until the server or a cloud level. So reliability means how you design the product, especially from the architecture point of view. What kind of a hardware architecture the companies adapt, starting again from the vehicles level to the component level. The component makers are the individual components in the vehicle, like ECU, sensors, actuators, and so on, and vehicle as a vehicle architecture. So starting from a vehicle architecture to the component or system architecture to the software architecture, the secure by design, is a important concept. So that provides the reliability.
Dr. Suresh, thank you for bringing in all the keywords that are being talked about in the automotive world today. Because to add on to what Dr. Suresh just told us, right? Software,
Yeah.
connected,
Yeah.
and a lot of other things, electronic, connected, ECU scans. One thing that instantly comes up in my mind is cybersecurity. And Suresh sir has himself mentioned, secured and reliable is going to be the basic trust factor from here onwards to go. Cybersecurity, to me and to a lot of other people in layman's language, means only protecting data. How does cybersecurity different fundamentally when it comes to automotive cybersecurity?
As Dr. Suresh sir said that cybersecurity is not something like you can fix like an antivirus. It cannot be a hot plug like normal computers have a virus, then you plug at a antivirus. Cybersecurity can be only fulfilled when there is a secure by design approach has been followed from a concept phase. What we say at HackersEra to the world, the cybersecurity is now a new seatbelt. So that means if you're talking about safety, you don't have to only talk about that. Okay, seatbelt is one of the key parameters. Nowadays, you can say that cybersecurity is one of the USP, one of the key features which will do the safety, which will ensure the passengers and drivers' safety of the vehicles. For example, let's say you are driving a vehicle on a highway and there is a 360-degree U-turn. Let's say it happened to the OEM or to the tier one, they cannot simply plug our, let's say, antivirus or something which will protect this kind of attack. This kind of attack will be followed when there is a proper requirement has given to the suppliers. Supplier will implement those requirements, supplier will validate those requirements, and then supplier will ship the product with cybersecurity to the OEM. And then OEM will integrate it, and then OEM will build the products and will ship to the customers. And then customer will see, okay, now a hacker cannot turn the 360-degree U-turn on a highway. This can be a mechanism which needs to be followed. Recent attacks you have seen on the Indian roads, which is on the e-rickshaw, which is already now giving the lot of buzz on our Indian automotive cybersecurity, where we stand today, why we have not done the regulations, why we have not done the checks when we are importing a products from certain countries, or while there is no regulations for such kind of cybersecurity testing.
I love that example of seatbelt.
Yeah.
Because the seatbelt design, if I am not wrong, the seatbelt has to be designed from the first very design of the car itself.
Yeah.
My question to you, Dr. Suresh, will cybersecurity also be needed to be designed and implemented from ground zero, or can it be put on to a vehicle later on? What are your views?
A good analogy. So if you look at the seat belt, it came as like an add-on, So all the while seat belt wearing was there, but it was an optional, and suddenly the regulatory framework came in and plugged in. But cybersecurity, though this comes in as an add-on now when the big change of mechanical mechatronics to electronics happening, but you can't just take the existing vehicle or existing architecture and do a plug-in. So because you can still try that, but how effective would be, because the hackers are very intelligent, that every time they find a new method to hack your laptop or hack your mobile, or the same hack your vehicle as well. So it starts from the architecture. So from the OEM point of view, what kind of an OEM architecture OEM wants to bring in, from his vehicle during the product development, and from then to the production, to the post production, until the life of the vehicle. You can't say that first 5 years the vehicle will have cybersecurity, after 5 years I just plug out from the scenario. No, it cannot, because any vehicle on the road should have that. So same now applies to the component developers, component designers like us, a tier 1 company. So we need to start from the architecture of the component, right? So then architecture of the system, then this has to get coupled with the OEM's architecture. So it has to be like from the scratch, where you build a reliable and a resilient software. This is what I was keep saying. I think this needs a different approach, architectural approach, and then you build on a strong foundation, and then foundation can protect for the future. And this has to be dynamically updated, because what happens is that every time you see a new operating systems, new communication way coming. Today we know CAN, we know FluxRay, we know Ethernet, but tomorrow it could be something else, And we know we were living with USB drives and OBD interface, which are physical interfaces, but in the future it could also be something different, So you need to dynamically update your platform or a module so that you are protected against these attacks.
I think because what I get from Dr. Suresh's explanation is that uh, cybersecurity in automotive is not limited to information security.
Correct.
It is more about functional safety.
Yes.
And what does that, while that difference on paper or in words may seem very, very simple and short, but is it really simple and short?
No, it's not a simple. I'll tell you. Let's say in IT security, what we have focused. We have focused on, let's say, there are different standards in IT security. What we have thought in, let's say, in a connected car, okay, we have to secure API. We have to secure, let's say, data where it stores data in transit and data in rest. But in automotive, it's everything related with the safety. If if it is not linked with safety, then why we don't need cybersecurity? For example, the that's Dr. Suresh said that today we have a technical protocols like Lean, FlexRay, CAN. Tomorrow it will be CAN FD. Tomorrow it will be CAN XL. So different protocols are getting introduced into the automotive domains. Now the thing is that on that protocols, what cybersecurity measures we can implement it. The implementation, what could be the possible, let's say, impact on the vehicles when this protocol will be hacked. There are a lot of ways to attack. There are a lot of attack vectors. There are 100 plus attack vectors to get inside the vehicles. For example, Wi-Fi, Bluetooth, let's say keyless. You have a key fob, keyless, then CAN bus, then OBD2 port, as you say, USB. Then when nowadays OTA came into the pictures, where you are flashing the software switching over the air or as well as from the OBD2 port. So the more the features, more the softwares, more the vulnerability will occur, and more the ways to it will open the doors for the hackers. Now, I know as a tier one, or as a OEM, as a solutions providers, we have to work on that on those cybersecurity controls which can implement on all the attack vectors. So you can see we have to make a multi-layer defense mechanism, not just a one layer. Okay, we have protected our access control. Now it's done. No, we have to work on hardware. We have to work on softwares. We have to work on, let's say, integrations, and we have to work on vehicle level control. So from that perspective, I see it's a very challenging one. It's not a static one. Like in IT, you deploy it, you add cybersecurity control, it's done. No, in vehicles, every cybersecurity will come with the cost, because you have to implement same cybersecurity mechanism into all the ECU, not just one ECU. And in a vehicle, 40 to 50 ECU are there. So it's a very challenging work.
Gentlemen, it seems that both of you have been reading my brain for a lot of time, because my next question, before I ask my next question, you give me keywords from my next question. Like in Vikas, said a lot of terms: CAN, ECUs, connected architectures, even the RF signals between the key and the key point.
Yeah.
If we wanted to understand in layman language, Dr. Suresh, what are the most vulnerable things when it comes to hacking? Uh, would it be CAN? Would it be OTAs? What would be the most unsecure that you would want to secure today?
Let's take a automobile as an example right now. Let me take two products where Spark Minda we are working on, which is more and more towards electronics, and more towards the complexity, and more towards SDVs. One of the product is a cluster. Okay, so a cluster is in the dashboard of a vehicle, which is called driver information system. See, in the driver information systems, where you display, the speed, and the engine speed, also various other telltales which is prevalent in the vehicle. This is one part of the story of the functionality. The other part is that this system also has connections to the external world. In some of the vehicles, it has a Bluetooth, it has a USB drive, it has also Android Auto, CarPlay. So the system gets connected, and also could also be telematics, for example. Cluster also has a telematics function. So when you have this complexity, you have the external connects to the device. So the device gets these inputs. So anybody who has a mobile with a basic secure, with a password exchange, you can get access to the cluster, right? Or a cockpit in a vehicle. So now, how you secure this is becoming important. It could also be that somebody has a interface like Android Auto, and with certain hacking logics, he can get access to the cluster and can display some information which, when you drive on a car on a highway, can give you a sudden shock, or sometimes you feel, oh, sorry, what is this? By the time you apply brake, it could be hazardous. It could be dangerous for somebody on that. Could be one example. Second example I can also give you, again, we used to have a simple mechanical lock, in the past. Now it is becoming a PEPS system now, passive entry, passive start, where you have a key fob, you enter the car, and car gives you an access, you start the vehicle and drive. Now this is becoming key fob based, and to become phone as a key, right? So which means you have a mobile with a Bluetooth or UWB, and then you go near the car gives you access, you get inside. So which means your car and the mobile gets connected, they talk each other, right? They communicate a language. If somebody breaks this, somebody hacker understands this communication and break it, and he can do anything. So this is where the complexity and then the solutions comes in, right? So from the architecture point of view, which I was talking about, for example, in the security of especially on the cyber related, there is a stacks called secure boot, secure OC, which is onboard communication, which is called SecOC, secure flash, JTech secure, and so on. There are various software stacks where you need to put in the electronic devices to make it more and more secure. But then the story never ends there. So you need to have an architecture which can handle. So let's say if 500 ECUs are there, you can't put this in all 500 ECUs. Then your vehicle price will boot up. So now you need to adapt an intelligent way of putting this. Probably one or two components in the vehicle is a primary holder of this, and other could be a secondary devices, and what kind of logics and algorithm you want to have between primary and secondary, that matters. So that's why I think it needs a strong architecture and implementation logic to take care.
Thank you, Dr. Suresh.
Just to add on it, in India, 4 lakh cases has been registered as a vehicle theft, but it was never registered as a vehicle hacked, because no one broke the glass, but vehicle is stolen. It should be registered as a cyber case, but it was not registered. So PEPS has been introduced to make people job very easy. To when you are going to the vehicle, you don't have to open the key fob and you don't have to press any button. It will automatically, because it's a passive entry keyless system, so it will open the door and you can get inside it. But hackers have found a lot of ways to break this, because it is RF communications, maybe encrypted, maybe unencrypted. Let's say if it's encrypted, we can do the relay attack. Maybe it's let's say not encrypted, then it's very easy. Then we can get captured. We can do the replay role. There are a lot of attacks. And just to add it, as Dr. Suresh sir said, that we have to introduce a lot of stacks into cybersecurity control. For example, this kind of RF attack, we have to also introduce a stack C. And let's say if you what regulations say or standards say, you have to do some kind of cybersecurity measures. Measures doesn't mean that you have to do the full protections. For these threats, I'm reducing this. For that, I'm introducing these stacks, and this is the label. This is a light label, medium label, or let's say full label. So this is kind of strategy that we can make to reduce the cost of the bomb, as well as to make our product cyber resilience. That is the goal. A standard or regulation will never say that you need to do the full protections. Full protection means all the ECU, you need a HSM, full HSM, everything. And there is also a concept called cyber relevance check. So before you implement any cyber security into it, you have to do the relevance check, whether what is the maturity that we need in these products.
Thank you once again, because you gentlemen are really reading my brain. Because the moment you answered, I was to ask Vikas that whether these vulnerabilities that Dr. Suresh was mentioning are more theoretical in nature, or are the engineers already seeing them as major vulnerabilities?
Today, you can see all the attacks which you have seen in the news, maybe from 2014, if you calculate I will not name any OEM today, but let's say a Jeep Cherokee, which is a very popular case study in automotive cybersecurity, I can name it that. In 2014, it happened, the first vehicle attacks, which was on a public news. 1.5 million vehicle was recalled after that incident. So it is not a theory nowadays. That time, the information was not in the public. Now you have every cloud, you have a Mythos, you have a ChatGPT, you have 505, you can get any, search it in different ways to hack vehicles, you'll get 100 methods. And then if you're a curiosity mind, you can do one by one attacks.
Yes.
So information are now in front of the public, and the curiosity, if you have curiosity, you can use those techniques to exploit the vehicles. So not anymore on theory.
What, according to you, Vikas,
Hmm.
will or is surprising or shocking OEMs the most when it comes to cybersecurity penetration testing?
It is not surprising. They have to do the maturity testing. Let's say once you are launching a product, you are doing a safety testing, correct? You are saying, you proudly say, I have a 5 ratings, I have 4 ratings. So it is your responsibility now to conduct the independent cybersecurity testing. The makers and checkers cannot be seen. That you have to remember. If you are making a product, you cannot test and you said, no, I have tested it, it's all okay. You have to get it tested by independent third party who are into this business, or who are the solution providers, or who are the authorized testing agencies. So that report you can count it as your verifications. So cybersecurity pen test is, I feel it should be mandatory. It is mandatory as part of 214. It is mandatory, but the OEM have to take this like normal case studies. They have to do the pen testings.
I think one of the follow-ups that an OEM would have a tier one, like with you, Dr. Suresh, after penetration testing is security by design.
Yeah.
Yes, right. But when I take this term security by design, what does this actually mean for a tier one? Companies that tier one is working with, and also the OEM that tier one is working with.
So
what does security by design actually stand for?
see, the secure by design is an architectural, a superficial topic, but then in reality, we need to go a little more deeper. It needs a collaborative work environment with OEM.
Yes.
A strong collaboration with the OEM, because when OEM defines the vehicle architecture, and then tier one trying to comply with the architecture, there is a layer in between called TARA. Threat analysis and risk analysis procedure, where OEM shares openly with the tier one about the different ECUs, different communication protocols, and how he is planning to take care of the risk. So then comes to the tier ones to work with the OEMs, design a solution which can meet to the OEM's expectation. This is one way. So then this comes in with certain solutions, which could be in the form of hardware, or it could be in the form of software. Nowadays, most of the chip makers have certain solutions which has inbuilt cybersecurity modules. One of the common terminologies which we use is called HSM or SHE, or combination of both. HSM is a hardware secured module, and SHE is a secured hardware element. Or the hybrid of both. So depending on the OEM's architecture, we can adapt one of these or both. So HSM, which is a hardware secured element, need a hardware chip inside your hardware, which is more secure. And SHE, which is a software hardware software element, SHE, which is a software which can reside, a logic software which can reside inside your SOC or a controller to take care of the cyber attack. And little more stringent is a combination or hybrid of both. But then again, this needs to be designed, implemented, and then finally comes into the pen testing, where whatever your implemented logic, whether it works or not, and then there are various ways to do the testing. There are third parties, as Vikas said. Obviously, you need to get the certification from there. The designer cannot do. You always need a third eye. And then obviously, in it could also take some more iteration. Maybe your first or second design, find some loopholes, and then you implement another logic to overcome that, and then you release finally the solution to the OEM. And then OEM does it at the vehicle level, component to the vehicle, and then finally goes to the end user. Then this doesn't end here, because cybersecurity again is a very dynamic. After that, how we are going to run this, how we are going to do diagnostic after few months or years. There are regular checks available on the vehicle by a OEM and a component guys to see whether they get some log from the field. And you can keep analyzing that, whether you get some clue from the field, whether somebody tries to do something or not. And then it is again dynamic, where you continue to enhance your security, because the system get regularly updated, mobile gets updated, your devices which you are connect to the vehicle gets updated. So you dynamically update your software. That's where the OTA comes in, over the air update. And then for that you need to have a software resilient inside the your electronic control units in the vehicle to take care of that.
On that note, Vikas, just a thought crossed my mind. Can a lot of stakeholders that Dr. Suresh
Yes.
counted on, right from chip to tier ones to OEMs and a lot of other partners who will be equally responsible for every bit of cybersecurity. Can I implement cybersecurity on a vehicle after it has been designed?
No. The simple answer is no, in a straightforward answer. After, let's say, you develop the product, you cannot do the cybersecurity implementation. Just examples. Let's say you have developed one, as Sir said, that you have a let's say IC, instrument clusters, that is designed now. Now you want to implement cybersecurity into it. So you need to go to all the tier one suppliers that, okay, hey, I want this cybersecurity to be implemented. This is my requirements. Let's say I have 10 requirements. Let's say few requirements can be done by the softwares. Then it's okay. But what if a requirement need a hardware change into it? Okay. And what if the current architectures is not supporting that requirement? For example, you, as Sir said, you need a SecOC, secure onboard communication, which protects all the inter-vehicle network communications between each others. The message authentications, then node authentication, then ECUs authentications. So, and you need it. But to have a SecOC, you need every module have a HSM. Either you need a light, you need a medium, you need a full. That will be depend on the cyber, let's say, relevance checks. But to have a SecOC, and let's say your architecture have a canvas, which is having 8 byte on, you cannot implement SecOC. When it required more than 8 byte, because where you can implement a checksum, you can implement the message byte encryptions, you can update the let's say nonce and everything. So then your requirements get failed. So you cannot have the, then if you're making a change in architecture, that means you're making a new vehicles. It's simple.
So you have to always look at the cost element. This is what I said. Affordable solution is key for a success. When you designed a product and then you start adding a fat, it may not give a solution. It may give a solution, but then finally for the end user, it is a bulky and a non-affordable solution. So it always starts with the architecture. So then only you can protect for the 100% secure and for the 100% towards the future.
Because R156, QSO 21434, these are terms to people, right? A lot of them would have missed these terms also. But beyond terms, what does these actually mean for them, for tier ones, for OEMs, for people like me? And where do you see them in the future? How important are they?
In a daily terms, these two words I will generally see every day, in every call, every conversations, R155, R156, and 21434, 24089. Just to give you, R155, R156 is a regulations. It means it's a, let's say, a rules that has been set by the United Nations, and all the governments are adapting it. 60 plus countries have been signed on that R155 and R156 regulations. What a standard says, standard is a, let's say, operating manual. That means you will follow that guidelines to achieve that regulations. So this 21434, it's a structural, it is a process defined to implement cybersecurity from organization level to product level, both. So you can follow two paths, one path for your organization, second path for your product development. If you follow correctly, you will meet the R155 or R156 criteria if you follow correctly the standard. This is what I mean. So in your journey, let's say when you are making the concept of your product, when you are making a specification for your products, you have to think on that whether it is aligning on standard or not.
And to just take from what Vikas said, there are UN regulations 155 and 156, and India has adapted regulations into Indian framework, which is called AS 189 and 190, which is similar to 155 and 156. And these are a kind of a rule books. Automotive vehicle has several such standards. Just we are talking now about cybersecurity, but then a lot of safety related standards, pollution-related standards, performance-related standards, and so on, where the homologation agencies check before they approve a vehicle or before they say yes to a vehicle launch. So same as well applicable to cybersecurity, where these two norms, AS 189, 190, where we have to comply with that. The comply to this means your design, and then it has to undergo certain checks by the regulatory authorities, and then they say once it meets this guideline or a standard, then they give acceptance.
My question to you, Dr. Suresh, these terms, these laws, how are they changing engineering teams inside Spark Minda?
Well, so that's where the strong engineering is required in the era. We spoke about the mechanical to mechatronics to electronic era, which we are talking about. The complexity is increasing when the customers require more and more comfort. Where the increased complexities bringing safety concerns, and you need to have the secured solution in place to offer these solutions. So a strong engineering, especially for the country, because India as a country is unique. We have the different architectures together. India is the only country in the world where all the powertrain scenarios exist. Whether it's EV or it's an ICE or it's an hydrogen fuel cell or LPG, CNG, and so on, ethanol mix, all scenarios exist. So you cannot adapt the same like how other countries could adapt. So you need to have a local solution, and this solution has to be acceptable to the wide OEMs, because again, a country is unique because we have Japanese OEMs, we have Indian OEMs, Korean OEMs, and European OEMs. Everybody has a different way of implementing, way of taking the standards. So you need a local engineering with a very strong fundamentals, and a bit more proactive to that. What we are seeing now, eyes on the bug, where we see the standards coming in, but we have to look slightly even beyond. What may happen 5 years down the line or 10 years down the line is also an important, because the powertrain change scenario gave a huge opportunity for us to implement these safety on the vehicle, because there is a change happening on the vehicle in terms of the architecture. So the OEMs try to adapt a change in a way to take care of the safety aspects as. So this provides an opportunity for a OEM, same as well for tier one, as we as a Minda Corporation. So we have a very strong team of engineers in Pune, and we have more than 1,100 engineers in Pune and Bangalore. And with our partner Flash, they also bring an additional tech center in Pune as well in Poland. So we have a strong engineering team in Warsaw in Poland. So we backed up with software and hardware, and we have a COE for cybersecurity. Knowing this, we set up a strong center of excellence in cybersecurity. So this team is seated in Pune, and functional safety. These two, so cybersecurity and functional safety, go hand in hand. You can't take a Xylo approach when you implement any safety logics. So we have a center of excellence in cybersecurity, functional safety, along with other software and hardware. So this makes us as one of the leading tier one in India.
Interesting. To expand this question a little bit more, Dr. Suresh, I wanted to understand, how has your collaboration with OEMs and other companies changed over the last 3-4 years, especially when you work on cyber security? I think you've already answered a bit about it when you said you've already established the Center of Excellence for Cybersecurity. But how has this relationship changed when you're working with OEM or with other companies in terms of cybersecurity?
Well, I said the collaboration is key for this, because either OEM or a tier one cannot have a Xylo approach in development. So you need a strong collaboration. The strong collaboration also comes with early engagement. OEM always have a roadmap for the vehicle, right? They have various launches sequenced over 5 years or 10 years, and they have a platform plan. And we as a tier one need to understand that. So that needs a very collaborative approach and a early engagement. When they already planned and they're about to launch in a year, you can't work with them. So at least 2 years before a platform, you need to work with the OEM. So we have very strong connect with the OEMs, and that comes with the confidence of the OEM. OEM will not just simply tie with anyone unless and until they have a confidence that yes, this partner can really do good for me. So then do some kind of a platform work with the OEM before this becomes a real RFQ. So that's what we mean by the early engagement. So we do with the engineering of the OEM. Of course, purchase also comes into the picture, but then work with them, understand their plan and their eco partners, who are their partners whom they want to bring in, and we together work on a solution. That's how it works, and it yields a result.
Thank you, Dr. Suresh. One last question to you, Vikas.
Yes.
Cybersecurity is an onus of tier ones. Is it an onus of chip companies, OEMs, government? Who should own the responsibility of cybersecurity?
As per regulations, it is OEM responsibility to have cybersecurity in it, in the products.
But who should have the responsibility?
Morally, it should be driven by OEM, but tier 1 should adapt it. So yes, this is
I think a strong partnership of OEM tier 1
What-
and tier 2 is essential, because while the standard may say the person who launches the vehicle owns it on the road,
Correct.
but then again, it cannot be a silo. It has to be a partnered way. Yes, he owns it, but then you also, tier 1 also owns with the OEM, where we have a contract with the OEM as well. So that way, a complete stakeholders get into the overall ownership and responsibility.
Perfect. One last question to both of you, gentlemen. The same question. 5 years from today, what would change in cybersecurity that is not happening today?
So for me, quickly comes into the intelligence, how you can bring intelligence into the cybersecurity, because for an end user, the security is become basic norm, right? That they cannot specify when they buy a vehicle, so it becomes a basic requirement, So the intelligence, how you can bring the intelligence, the AI now, artificial intelligence is coming in a big way. How we could use this kind of AI to bring intelligence on board on the vehicle is becoming a very, very important topic. I feel 5 years down the line, AI will do a lot of role, a big role, an intelligence role, and that needs to be handled carefully by OEM as well the tier ones. So we have to see how we adapt in our development, in our software, in the logics, these AIs, and make the system more and more powerful, more and more immune, and more resilient, and more reliable. This is what we have to do it. And this comes with a design, secure by design, by adapting whatever we said, the various software stacks, hardware modules, we can make it more and more reliable.
I'll
Thank you.
just go in deep a little bit. So as you know that before AI was in the news, PQC is, timeline was 2030. PQC is post quantum cryptography, but timeline was 2030. But now after the cloud made a lot of buzz into the Fable 5 and Mathos, so it became 2028. So 2 years has been preponed now. What does it mean? That every cryptographic today you are using in automotive, let's say whether you are using EDSA, whether you are using RSA, it's going to be break in 2028 because the cloud or AI is in the pictures now. So that means in our development, we have to be very agile to use the AI native in our development, in our testing, in our, let's say, concept creation, requirement creations, in our hardware BOM selections. So we can adapt this kind of changes are happening currently to be more cyber resilient with the AI. So AI can be defensive, AI can be offensive also. So if I'm a hacker, I can use the AI ML techniques to penetrate our software, penetrate our products. But as Dr. Suresh can use it for the defense purpose. So this is how we have to make the agile of our development as well as the validations framework.
Thank you. Thank you, Vikas. Thank you, Dr. Suresh. I think key takeaways from me from this dialogue today with Dr. Suresh and Vikas is functional safety and cybersecurity will have to work in hand. They are not going to be working in silos. Second, advanced intelligence is going to play a major role. And the most important one is going to be cybersecurity is not just a responsibility of OEM, but is equally a responsibility of tier one, equally of companies like HackersEra, and cybersecurity has to be embedded onto a vehicle from day zero.
Yes.
This is Mukul Yudhveer Singh signing off for Autocar Professional, and we would meet again soon for more cybersecurity dialogues. Take care.